All right, so we're going to continue looking at logarithms, okay, section 7.3. We're going to do a couple things. We're going to learn some properties to simplify logarithms, kind of like the, I closed it, but the problem we had in the homework last night. I told you there was a shorter way to do it. You'll see that in a second. The other thing we're going to look at is how you can take two logs that are separate and combine them together. Okay? Or you could take two logs that are combined and separate them if you want. But usually we like to combine them to make them simpler. And the last thing I'm going to show you is how to type in logs other than the two bases you can do by pressing a button. If you press this button, what base is that? Yep, that's base 10. And what if you press the one below it? What base is that? Yep, E. Okay, base 10 and base E are the only two logs you can type in just by pressing a single button. So how do you type something in other than those two? I'll show you in a little bit. Okay, but you can type it in, it's just not a single button. All right. So first thing we're going to look at is just some special properties to simplify logs. There's no real arithmetic or calculations you need to do. It's just a special pattern when certain things cancel out. All right, so let's look at the first one. Okay, so the first one says a raised to the log base a of m. Did anybody notice something there that matches something that's used twice? Yeah, the a. Okay, so whenever you have that pattern, okay, if I did it with numbers, it might look like this. 3 to the log base 3, and then pick something different. 5. If you have something that has a pattern where these two numbers match, what basically happens is that all cancels out. And what you're left with for the answer is whatever is right there. Okay? So it's just a special pattern. Okay? But in order for it to work, these two numbers have to be the same. So what would the one up above simplify to? If you typed all that in, yeah, you just get 5. Okay, we don't even know how to type this in yet because we don't know how to type in a base 3 log. Okay, and even when we do, it would be kind of complicated to type all this in. You just have to recognize that special pattern. Okay. Any questions on that? Okay. Second one. It's another special pattern, but this time it's a little different. The first one had a log in the exponent. This one doesn't. Okay. So an example for number 2 might look something like this. Log base 4 of 4 to, and then pick a different number, 12. Okay. If these two numbers match, it's kind of the same idea as the last one. This part basically cancels out as long as those a's match. And the only thing you're left with is that exponent. So if we looked at this one, since the 4's match, it's going to cancel out. And what's the only thing I'm left with? 12. Just a 12. Okay. And that's it. So it's just a special pattern. Any questions on that one? All right, let's take a look at this one for a second. Okay, I want to see why this one's true. And I can look at why the first one's true, but let's just look at the second one. What is my base in number 2? No, sorry, just in the theorem. A. That's my base. What's going to be my exponent? That's my exponent. And what is my argument?
Log of the A. Or log of A.
No, log's not the argument. Log is the function name. So logarithm, that's like sine or cosine. It's just the name of what you're doing. But what's my argument? Okay.
A to the power of r.
A to the r. That's what you're taking the log of. That's what's getting plugged into the log function. So how is number 2 written? Is that an exponential equation or is that a log equation? It's a log equation, okay, because it has the word log. That's not an exponent. So let's change it from log form to exponential form and watch what happens. All right, so we said the base was A. So I'm going to use the same color as the box when I rewrite it. So the base was A. What was the exponent? R. That was the exponent. And the only thing I have left is the argument, A to the R. So the reason why this formula is true is it's just saying that something is always equal to itself. That's all that this rule says. Okay? You probably saw in like geometry or something like that, x equals x. Sometimes they call it like the reflexive property. Something is equal to itself. Well, it's really what this is. It's the reflexive property, written as a log, not the way you saw it in geometry. Any question on rule 2? Okay, in rules 3 and 4, we're going to look at why those are true. And it's also going to be basic reasons from Algebra 1, okay, why they work. If you take the log of 1, the answer is always 0. It doesn't matter what the base is. If you take the log of 1, the answer is always 0. Okay, let's rewrite this one and see why. Katrina, is that a log equation or exponential? It's log. So let's rewrite it as exponential, and I think it'll make sense why it's true. What's my base here, Katrina? A. That's my base. What about my exponent? 0. And what's the only thing that's left? 1. All that rule 3 is saying is if you take anything and raise it to the 0 power, you always get 1. That's a rule from algebra. Anything to the 0 power is 1. That's why this rule is true. Okay. Any questions on that one? All right, and the last rule says that if you take log base A of A, you're always going to get a certain answer. Anybody have a guess what you're going to get there? Like if you did log base 2 of 2, or log base 7 of 7. Yeah?
4.
Yeah. You're always going to get 1. And let's look at why this one's true. Kate, what's my base here?
A.
Yeah, which one? The lower one or the higher one? Yeah, that's my base. A is my base. Jasenia, what's my exponent? 1. Whatever's by itself. That's the exponent. And the only thing I haven't used is the other A. All that rule 4 is saying is that if you take anything and raise it to the first power, it doesn't change it. Okay? Hopefully a rule that you already knew. Raising something to the first power doesn't change it. Okay, so these things on the right, these are just the kind of the reasons why the rules are true. But what you really need to know is the rules on the left. So any questions on those rules? All right, so let's try, just see if we can identify what rule it is and then use that rule to simplify this. Okay, Brian, what rule does that one look like? Rule 1. Yeah, that's rule 1, where you have 2 in place of A and pi in place of M. So what would you get if you use rule 1 and simplify that? Yeah, you just get pi. And that's it. That's all you have to do. Any questions on that? Okay, Eric, how about that one? What rule does that one look like? Let's see.
Well, I know it equals -4.
Okay, and what rule tells you that? 1? No, it's not 1 this time. 1 would be if you've got a log, but it's up high. So this one doesn't have a log that's written up higher as an exponent.
Number 2.
Yeah, this is rule 2. Just change a to 0.2 and change r to -4. Okay, so that's rule 2. And it comes out to -4. Okay, how about C? The ln of e to the kt. That is one of our rules, but it's not quite as obvious which one this time. I don't think they see which rule that one is. Yep, no one? It is rule 2. Can you tell me why? Or can you rewrite that?
You change log, and you change to log e, and then another e.
Yeah, change this to log base e. And then copy down the rest of it, e to the kt. Now it's more obvious that it's rule 2. So what would the answer be, Nolan? Yeah, k times t, whatever k times t is. All right, let's see, I didn't do one for rule 3 or 4. Let's take log base 12 of 12. Marquise, what would log base 12 of 12 be?
Rule 4.
Yep, that's rule 4. And the answer would be 1. And we could do, let's do log base 7 of 1. Now, we don't even know how to type in base 7, but it doesn't matter. We just have to use the formula and we won't need a calculator. So what's log base 7 of 1? Well, Alyssa? 0. And what rule tells you that? Yeah, rule 3. Okay, so that's the kind of problem you'd see on the test on this stuff. Just simplified, just like that. Okay, any questions on that? And I think, I don't have the one in the homework open, but the one in the homework was, where was it? Something, it was the ln of e to the -2x equals 8. That's kind of like the one I just did right here, except instead of ln of e to the -2x, it's ln of e to the kt. Well, if you knew this rule, you could basically have canceled all this out, and it was something like this, equals 8 or -8, something like that. So this rule is a nice shortcut for that homework problem. You don't need it, but it's a shortcut. Okay, questions on those properties? All right. So we're going to look at some properties now we can use to take logs that are separate and combine them, or take logs that are already combined and you can separate them if you want to. What do you think has to happen in order to take two logs and be able to combine them? What do you think each log has to have in common? Because like you can't just take anything and combine it. Like if I tried to say take 2x plus 3y, you can't do it. But if I said 2x plus 3x, you could do it because they have something in common. Logs, it's not quite like that, but what do you think they would have to have in common to combine them? They have to have the same base. Okay, that's part of it. So I could take something like this and something like this, and I can combine those together. Anyone have a guess how those would combine? It's a little harder than my first question. Yeah.
Would it be log base 2, 8?
Okay, I like the idea of keeping the base the same. That's going to happen. But it's not going to be 8. It's a good guess. You might think, oh, 3 plus 5 would give me 8. But it doesn't quite work that way. But this part is correct. But it's just a different number that's going to go there. It's not 8. Yes. So it actually ends up being 15. It's not a hard calculation. We just have to know what we have to do. Okay? So they multiply together and you get 15. So here's the first rule, just written out in general. If you have two logs that are separated with an addition sign, okay, like I did, and you want to combine them, you end up multiplying them together and you keep the base the same. Or you can look at that the other way. If you said, well, what if I had something like this and I want to split 15 apart, okay, into two separate logs? Well, you can split it apart as a sum, and you just have to put the first factor here and the second factor there. So here's an example with the number 20. To split log of 20 apart, the first thing you have to be able to do is find two numbers that multiply to give you 20. So I get 4 and 5. And then I can split a product as a sum. That's how it splits. Product splits apart as a sum. Your first argument is the 4. Your second argument is the 5. And the base stays the same through the problem. The base can be anything you want. It can even be base E. So you could do this with LNs as well. Okay, and I'll show you how that one works. Okay, so I'll type in log of 20. And then I'll type in log of 4 plus log of 5. Now I picked a specific base to use because it was easy. What base did I just use? 10. But I could use base 8. I could use any base I want, but 10 is the easiest one for me to show you. Anybody think of a different way you can multiply to get 20 besides 4 and 5?
2 and 10.
Yeah, you could do 2 and 10. So if you did 2 and 10, it would look like this. Okay, so what I'm trying to show you is there's more than one way to split it apart. Any two numbers you can think of that multiply to give you 20. You could do 40 and 1/2, because 40 times a half is also 20. Okay. So any questions on taking a product and splitting it apart as a sum? Okay. Let's look at the next one, which is a quotient. So if this follows any kind of pattern, and a product splits as a sum, what do you think a fraction would split as? What? Yeah, it's going to split as subtraction, okay, or a difference. Okay. What's important here, though, is that you do the log of the first argument, or the top argument, minus the log of the bottom argument. You have to do them in that order. With rule 1, it's not as big of a deal because it's addition. You can add any way you want, technically, get the same thing, but not with subtraction. Okay, so it's log of the top minus log of the bottom. You could check that. You could type it in and see that this will work. I'm not going to type this one in. But the log of 4/5 equals the log of 4 minus the log of 5. Any base you want to use, 10, E, or anything else. They'll give you the base in the problem. So just whatever base they give you in the problem, keep it the same through the whole problem. Okay. Any questions on rule 2? All right, so rule 3. Let's take a look at this one. This goes back to the first rule we just learned. How would this split apart? I have the log of x times y. Yep.
Log x plus the log of y.
Yes. Now, that rule works if you want. You can use it for more than two things. Like if you have this, something times something times something, you could split that as log x plus log y plus log z. Right? So you can have as many things multiplied together as you want. Let's look at this one. Log of y times y times y. How would that one split? About Claire? Can you tell me how that would split? Kind of think of it, you know what, if I even take a step back. It's like y cubed, right? Y times y times y. So same question, how would that split? Sure. Well, when you split up a product, does it split as a sum, or is that a difference? It's going to be a sum. Okay, how many things are you going to be adding up once you split it apart? You're going to be adding up three things. So you have something plus something plus something. Rebecca, can you tell me the first thing I'm going to have? Yeah, it's going to be log y. And Selenia, how about the second thing?
Log y.
Log y again. And Claire, how about the third thing? Yeah, it's going to split into log y plus another log y. So how many of the log y's is that? Well, Jared? Yeah, it's three of them. So the shortcut, if you look at what you started with, look at what you ended with. Does anybody see a shortcut to just go right from this step to that step just by moving something? Yep. Yeah, that's the third rule. Take the exponent and put it in front. Why does it work? Because of what I just showed you. So instead of going through all these extra steps each time, anytime you have an exponent, you can take the exponent and put it in front. So rule 3 is really just like rule 1, except instead of having different things you're multiplying, it's the same thing multiplied over and over. That's all. So here's another example with numbers. Log base 10 of 3 to the 5th. You're allowed to take the 5 and put it in front. Okay, and if they want you to do this in a problem, I'll show you in the next step how they would write the directions. Okay? Because unless they say you don't have to do step 3, but most of the time they are going to ask you to do it. And the last thing that we need to know from algebra is how to write this, but as an exponent. Anybody remember if you take a square root of a number, that's the same as putting a certain power in that box. Does anybody remember what square root is the same as? X to the... No, x squared and square root, those are like opposites. But it's kind of close. 1/2. Those two things are the same. Actually, I think I already had that written. Yeah. just show you an example. I'm going to take square root of 16, and then take 16 and raise it to the 1/2. Same answer. And the reason why you might want to change from having a square root to having a 1/2 power, you'll see why when we do a log problem. Okay. So, any questions on that rule? Okay. So I'll do one at the end with this rule, but to start with, I'm going to keep it a little simpler. All right. So the directions here say to take that log, and they want us to split it apart. Okay, write it as either a sum or a difference. So either use rule 1 or rule 2. And then, after you do that, don't leave numbers in the exponents. So when they say express powers as factors, factor means put the exponent in front. If there is an exponent. This problem doesn't have one. The next one will. Okay, so when I go to split this up, first thing I decide, does this split as a sum or a difference? It's a sum, because we're multiplying 3 times x. So we're going to have a log, and have a log. What's going to be the base on each log? Yep. Base doesn't change when you split it. And my first argument, and second argument. That's it. So we took that log that was already combined and we split it apart. They get a little harder than that, but that's the basic idea. Any questions on that? All right, let's try this one. Shannon, is this one going to split as a sum or difference?
A difference?
All right, so difference means that inside that argument we have a fraction. Do we have a fraction inside it? No. So there's no fraction in this one. There's going to be, I think, in the next one. But in this one, we still have multiplication. Something times something. Okay, so that's a sum. Okay, how about, Sam, what's going to be the base when I split it as a sum? These two. Skylar, what's going to be the first argument?
5.
5? And how about the second argument?
R to the third.
R to the third. Now, up until now, everything we've done is correct. We just haven't done the last step. They said to write powers as factors. So that means, Jared, I'm going to take this 3 and do what with it? Put it in front. So either rewrite it as a new line or just move it in front like I did. Okay. If this was a multiple choice question, I might write this as an answer, and I also might write that as an answer. This one is wrong. Okay. If it says to put powers in front, write powers as factors, that is not correct. Make sure you do it like that. Any questions on that one? All right. So let's try log base 9 of x divided by 2. Okay, take like 20 seconds and see if you can split that one up on your own. All right, so John, can you tell me the whole answer, how you split that up?
Yeah, I did. Log base 9 of m, x.
Yep.
Minus log base 9 of 2.
Perfect. What's that? Log base 9x minus log base 9, 2. Any questions on it? It's pretty straightforward because that one only uses one rule. I think that's rule 2. Okay, this one will combine 2 rules. And anyone think they can tell me the final answer here? After you split it, and if there's any exponents, move the exponents where you have to move them. And it's the same with ln. Just leave ln in the final answer. You don't have to write log base e. Selenia?
3 ln1 minus ln8.
Perfect. That's it. 3 ln1 minus ln8. Okay. Any questions on why she put the 3 in front or how she got subtraction out of that? All right. I'm going to rewrite this one. So we'll do one more kind of easier one, and then we'll go to the last one, which is the hardest one. Let's do log of 2 times the square root of x. Right, so Dan, is that going to split as a sum or a difference? Yeah, how do you know? Exactly, you've got multiplication. Okay, 2 times the square root of x. What's going to be the base on each log, Dan? 10. I didn't write a base, so we're assuming it's base 10. Log base 10, which if you write it, that's fine, but you don't have to. Of 2 plus log base 10 of square root x. Now, this is one that if you stop here, this is wrong. You haven't done anything wrong yet, but you haven't finished it. It said express all powers as factors. Does anybody see a power in that problem? There is an exponent in that problem. It's hidden now because of the symbol we used. Yes, this is an exponent. It's hidden in that square root symbol. Okay. So, what you want to do is change the square root of x to what we said. Okay, it's a 1/2 power. And then where does the 1/2 go? It goes in the front. That's the one that most people get tripped up with. Okay, so remember, make a note, on your reference sheet or whatever, if you have a square root, that has a hidden exponent. You have to put a 1/2 in front. Okay, and there will be one very similar to this on the test, and I will list both of these as choices. The bottom one is correct. The middle one here is wrong. Okay. All right, so let's go to the last one for splitting. It's got more stuff in it, but there aren't any additional rules. You're either going to split it as a sum, a difference, or if you have some multiplication and division, maybe you'll use both. And any square roots or any exponents, we'll move those to the front. Okay, so start by looking at your argument. Do you have a fraction there? You think, Jason? Yeah. If you have a fraction, deal with that first. The way you deal with the fraction is that turns into subtraction. Top minus bottom. So you're going to have top minus what's in the bottom. So now, at least what we've done is we've split what was a really complicated argument into 2 simpler arguments. So now we have square root of x squared plus 1. That's my first argument. And then x cubed times x plus 1 to the 4th. That's the second. There's not a lot I can do with this first argument, okay? Because when you have addition, there's nothing you can really do with addition. Just multiplication and division. But there is one thing I can do here. And we did it in the last problem. Karen, do you see what I have to do with this argument? Change, you want to put in what? I just didn't hear, what did you say?
The square root of x squared, change it to x.
Close. I don't want to do anything to that 2. That 2 is going to stay where it is, but we're going to change all of what's under that root to the 1/2 power. Okay. You can't cancel that 2. So this turns into that. Okay. Let's stop for a second. What do you get if you do that? What's the square root of 4 plus 9? It's the square root of 13. What's the square root of 4? And what's the square root of 9? 3. So which one is correct? Square root of 13 or 5? Square root of 13. So when you have addition under a square root, you can't take the square root of each number individually. Okay? That's why you can't simplify this x squared. You can't do anything to either one of those individually. Okay? You just have to take the whole thing, put it in parentheses, and put 1/2. Okay? Don't try to do anything else. Okay. All right, so now that's all we can really do with the first argument. Now, how about the second argument? We've got multiplication. Okay, how is that going to split? About page. It's going to be an addition sign. And what's going to be the base on each log? Yes, thank you. I forgot the A. That was my fault. So the A is going to be the same on both. And how about your first argument?
3 1 to x.
Okay, I wasn't even going to do all that at once, but you can. I was just going to put an x cubed here, and then in the next step, I was going to put the 3 in front. But that's fine. And can you also do the last one for me?
4 1
Yeah. I was going to do x plus 1 to the 4th, and then in the next step, I was going to move the 4 in front. But if you do it all in one step, we're pretty much done, except for this 1/2. What do I have to do with that? I need to move that in front. So for me, it's rather than rewriting the whole problem, just do it like that. And it is important after that subtraction sign you put those brackets, because you're not just subtracting this part, you're subtracting everything that you split. Okay? So both of these are subtracted. So it's like that minus is distributed to all of the stuff that was there originally. Well, that's it. That's really the hardest kind of log problem you could have. And the thing, I think, when you're taking a log that's already combined together and you're splitting it, it gets worse. Because you're taking something that was already kind of just together as one thing, and you're making it more and more things. So I think what we just did is the harder of the two things we're doing. The other thing is to take and put it back together. Okay, I like doing it this way more because then at each step it simplifies. Right? It's getting smaller and smaller. So to simplify it, you do everything we did here in reverse. Okay, so without me really saying anything else, anybody see what you would do first here? Think of what you would have done last to get to this step. And that's the first thing you're going to do here, to start reversing everything. Jesse?
What would be the x1 and
Yep. put the 4 back as the exponent. And 3 to the 4th power is going to give me how much is 3 times 3 times 3 times 3? 81. Yep. So we'll do that out. And now my last step is to recombine 7 and 81, and it's addition. So John, when I have addition, how do the two arguments combine back together? No, we don't. When we have addition, it wasn't addition originally. It was you multiply them. Yeah. And 7 times 81 is 567. Okay. Any questions on that one? And that's it. Just stop right there. Now, if I was going to have you split that back apart again, everybody might split it a little differently. It's kind of like the number 20. Many ways you can split it. But I'm not going to have you split it apart again. Okay, how about this one? 2 log base 3 of u minus log base 3 of v. Jake, can you tell me how I do that one?
We would put 2 as the exponent of u.
Yep, put the 2 back. And what would you get for the final answer?
We would get log base 3,
Mm-hmm.
u to the second v, or v u to the second. Or, yeah, u to the second with over v.
Divided by v. You're going to have division in this one because we got subtraction. And that's it. Okay, in this one, there's no numbers for u and v, so you can't simplify. Sometime what they might say in the homework, and this throws people off, they might tell you that u and v are greater than 0, only because if they weren't, you would have imaginary numbers. So if it says in the homework u and v are greater than 0, it doesn't change anything. Just ignore it if you want. They're just saying you're not doing imaginary numbers. And you're also not dividing by 0, because v is bigger than 0. Let's skip that one. Let's go to this one. Okay, so like the last one, this one looks like it could be pretty complicated, but you can do it all in one step. The first 3 arguments are added together. When you recombine it, what does addition turn into? Multiplication. So it's this times that. Literally, you can just write it like that. Yeah.
So it'll be log A 9 parentheses x.
Yeah,
1.
9x. Yep. And then divide by 5. Because it's minus 5. That's it. Okay, so you just multiply everything that was added, and you subtract what was divided. Or you divide what was subtracted. Okay, any questions on that one? All right, so last thing I'm going to show you is how to do something on the calculator. All right, so right now, if I asked you to find this, everyone should be able to do it. Okay, you just go on your calculator, find your log button, log 6, and you can do it because it's base 10. Okay. If I asked you to find the ln of 4.2, okay, that's something else you should be able to do because you have a button for it. But if I asked you to do something like this, I want to know the log of 8, but I'm not using a base 10 and I'm not using a base e. How do I type that in? Okay, so that's what we're going to look at. How do you type something in that's a base besides 10 or e? Right, so let's start with basically what I've written right here. Okay, except I'm not going to use a 3 and an 8. I'm just going to use, it could be any numbers, positive numbers. What would this be if you rewrote it in exponential form? What to what power equals what? Shakira?
But it's a power of y.
Yeah. A to the power of y equals x. Okay, now the next step, it's a little bit of a trick, but I'm going to take the log of each side. As long as you do the same thing on both sides, that's fine. Take the log of each side. So you might be like, we just got rid of log. Yeah, I know, we're putting it back. So I changed it from log form to exponential, and then I took the log of each side. What can I do on that left-hand side now? There's something here that we just learned. Anybody see one of the rules we can use?
The y.
Yeah, what can you do with that y? You can put it in front. And the other side stays the same. So the whole goal is to figure out this, okay, which is equal to y. Well, what would be my last step to get y by itself in this equation right here? Move the log a to the other side by dividing by it. So you end up with y equals, which is exactly what we started with, y equals, but we had something here we had no idea how to type in. Now I've got something here I should know how to type in, because what's the base on each of these logs? It's 10. It's not a anymore. It's just a 10. All right? So if you want to take a log, okay, and you have a base that's not 10 or e, all you have to do is take the log of the argument and divide by the log of the base and use base 10. And that's called the change of base formula. So to do log base a of m, take the log of the argument and divide by the log of the base. And I did it with base 10 when I explained how to do it, but technically you could do it with base e. Both of these come out the same. Pick one and remember how to do it. You don't need both. I'll do both in the first example to show you they're the same, but I usually just do it this way. Right, so I want to find log base 5 of 12. Okay, don't have a button for base 5 on the calculator. So I have to rewrite it using the change of base formula. Every time you rewrite it, it's going to be a fraction. And what's going to go on top? Just any?
Log 12.
Good. Log 12. And what's going to go on the bottom?
Log 5.
Log 5. That's your answer. If they want to know it as a decimal, just type it in. Okay, you can't do this without a calculator. So it's log 12 divided by log 5. If you did it with ln, you get exactly the same thing. ln 12 divided by ln 5. Okay, but just learn one of the two ways to do it. What's that, about 1.54. Sam, did you have a question? Okay, and let's we'll finish up with log base 3 of 16. All right, so Connor, how would I rewrite that so I can type it in?
Divide the log. You divide by
Okay, so you tell me what I press.
So you can get 16 by
I want the answer to this. I want to know what that comes out to.
log base 16, or log 16,
Mhm.
log divided by log 2.
Exactly. Okay. Type it in just like that. Log 16 divided by log 3. Okay. Any questions on that? So it's really not that hard to type in things with a different base. You just have to type it in as division. Okay? And that'll work on any calculator as long as you've got a log button. You don't need a graphing one. Okay. So any questions on the change of base formula? All right. Okay, so homework tonight in 7.3, it's on 485. 7 to 15, just do the odds. 31 to 33, that's all, so 31, 32, 33. And then 39, 40, 51, 52, and 65 to 69 is just the odds. Okay, I will be after school tomorrow for extra help. Okay, if anybody needs to stop by before the test, don't forget it is our last test. Okay, so this is really the end of your term 2 grade on Friday.